All right, y'all, I'm going to talk to you about a simple rule in chemistry that's not perfect. And it's called like dissolves like. And what it's saying is that polar substances will dissolve in polar liquids or polar solvents, and that nonpolar substances will not. And it also says that nonpolar substances will dissolve in nonpolar solvents, and that polar solutes will not dissolve in nonpolar solvents. So I'm going to give you a little idea. Now, when we're talking about polarity, let me tell you what I mean. If we're talking about NaCl, that's polar. These two sides are different. Now, some of you are like, well, Mr. Perkins, you told us if you had something drawn like this with MgCl2, that would be nonpolar. I'm not talking about that. I'm talking about between these two guys right here. They're very, very different. This is positive, that's negative. So anything that's ionic is basically has the most polarized bonds. Remember when we talked about Linus Pauling's chart of electronegativity? The more different you are, the more polarized your bonds are. Let's take a look at salt. Salt, beep, boop, boop, dissolves in water. Remember we said water was polar? It's got a negative end up here. It's got a positive end up here. It is bent, and therefore it's polar. So I'm going to get some water, and I'll be right back. Magically, there I am with the water. This is just water. Now, let me get some salt here. This is just table salt. Table salt is ionic. The bonds in it are very polar. Water is polar. So guess what? These two things are alike, and we're going to say like dissolves like. We like that. All right, here's some water. Take a little table salt. Boop, 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 boop. You can see it in there. I'm going to... That white background's not helping us very much, is it? There we go. Now, I put a lot of salt in there, but you can see that the salt is dissolved. Well, now I still got some in there. There we go. Dissolved. Does that make sense? Now, what I'm going to do is I'm going to get some of the salt. I'm going to try to put it into something that is nonpolar. What is something that's nonpolar? Okay, oils are nonpolar substances. Oils, petroleum. I've got some WD-40 right here. There's the label. And I've also got over here on the floor some race gas. Let me be right back with some race gas. Okay, I've got some race gas here. This is just really, saying it's race gas is wrong. It doesn't really have toluene or anything in it. But this is 93 non-ethanol 2-stroke with synthetic AMSOIL. It's for my daughter's race bike. So this will make that 65 hum. But here is basically, this is a non-polar solute. Is a non-polar liquid. And let me dump some salt in there. Boop. Shaking, shaking, shaking. Did it dissolve? Nope. There's all the salt. Let's try it some more. And nope, all the salt is still there. See, that's just getting funky and sort of, I don't know, just getting clumpy. But I'll tell you what it's not doing, and that is, it is not dissolving, it is not dissolving. And the salt will just sit there. It just made some funky looking clumps. It's not going to dissolve in that gasoline because salt is ionic. It's got the polar bonds, and gasoline is nonpolar. So like dissolves like. Well, these two are not alike. Wait, I've got an idea. Why don't we do this the other way? Cool. Now here's my water again. I'm back to water. Back to water. I'm out of my salt. But let me think if I brought any cool powders from my chemistry lab out here to the dirt bike barn. Oh, I did. I brought some sulfur. The formula for sulfur in this powder form is S8. In other words, it's just a bunch of sulfur atoms stuck together making a molecule, that is completely nonpolar. All of the atoms are alike, so how could it possibly be polar? How could there be different ends? So I'm going to take some of this sulfur and I'm going to put it in water. Now water, as we said earlier, is polar. Sulfur is nonpolar, so we would not expect these two to work together. All right, there we go. Just put a little bit of sulfur in there, and it is floating around. Try to mix that up real good. And nope. As a matter of fact, the sulfur is still dry. Let me get it out here for you and show you. Sulfur is still dry. Like, it absolutely does not dissolve. So, what if I said, forget the water, let's go back to the race gas. What if I tried to put, this is a nonpolar substance, this is a nonpolar solute, this is a nonpolar solvent. What if I tried to put this in there? Are those two alike? Yep. Nonpolar and nonpolar, like dissolves like. We would expect this sulfur to actually dissolve in the race gas. Put some in there, look, it instantly dissolves. Boop, 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 doesn't float at all, gone. Here we go. The sulfur is gone immediately, dissolved immediately. So, ladies and gentlemen, like dissolved in like, and my like salt, which was polar, dissolved in the polar water. The nonpolar sulfur did not dissolve in the polar solute. The polar salt is still sitting in the bottom of the race gas. You can still see it still sitting there. So, yeah. Ladies and gentlemen, that is like dissolves like, and there's really nothing more to it. Here is your assignment. Your assignment is to do a Google document, send it to me, and come up with 3 powders that should dissolve in water and 3 powders that should dissolve in race gas.